Welcome people to Java for Noobs Tutorial 1. My online name is Novice and you can reach me at xxnovice. The O there is a numerical 0, xx@hashmail.com if you have any questions. So what will we be handling in this tutorial? We will be looking at some theory relating to Java, why you would want to be a programmer, what object-oriented programming is. We will download and install Java. We will also download and install NetBeans. We will write our first program and we will write an addition program. Now don't be too scared. Learning how to program is like learning how to read. In the beginning it seems quite daunting and challenging, but as you go on and do it more and more often, you'll eventually get used to it. So do not be afraid. So who am I and why do I think that I can teach you programming? I'm a junior software developer and I work with Java in industry. I also work with Oracle ADF, SQL and PL SQL. I do, however, not have a diploma or degree yet. I'm a programming hobbyist and I'm also a private Java tutor. I occasionally write for our internal newsletter at the company about numerous information technology related topics. I've worked with C, C++, Visual C++, C#, Java, and so forth. And I've also played with the Arduino board and the Raspberry Pi board in my free time. So, question to you. What is the most popular programming language today? Take a wild guess. Yes, according to multiple sites, it is Java. So why is Java so popular? And that is one of the questions I'll be trying to answer throughout this tutorial. So why would you want to learn Java? Java is widely used. It's taught in many schools and universities, which means it has a large community, which means there's a lot of help. If you get stuck while you're writing a Java application, you can simply go onto Google, type your question, and most likely the answer is going to pop up. And if not, there's going to be hundreds and thousands of developers that will be able to help you. Java is good for internet-based applications, networked applications, and mobile applications. And Java is in fact such a popular language that 3 different versions of it exist. You get Java SE, which is Java Standard Edition, which is what I teach. It's usually the edition that you will learn first. Then you get Java ME, Micro Edition, which is for smaller devices. You can use it to code, for example, the Raspberry Pi. Then you get Java EE, which is Java Enterprise Edition, which is for larger corporations that have to tackle large-scale problems. And Java is what we call an object-oriented programming language. I will be looking later on in the tutorial what exactly object-oriented programming means. So, why would you want to be a programmer? Programs are used for smart devices. The jobs for programmers are in high demand. You get a decent pay. Corporate companies make use of programs. Governments make use of programs. In the entertainment sector make use of programs. Gaming sector make use of programs, mobile applications use programs, your washing machine, your fridge, your oven and cars use programs. And it's a field that you will constantly be learning in, because every 2 years or so something big happens in the information technology field, so there's always something new that you have to learn. And this field is of course always constantly evolving. And this means it's exciting. You never get to do the same things over and over and over again because there's always something new. Hardware and software. It's important to know that software controls hardware. When we write software, we're actually writing something that we call logical decisions, because the computer is too stupid to on its own know what it's supposed to be doing or decide by itself. The programmer instructs it by writing lists and lists of logical decisions, which in the end forms a program. Computers is brilliant at doing computation and doing it extremely quickly. For everybody in the whole world, this little laptop sitting here before me is powerful enough to do so many calculations, probably 1,000 or 10,000s of time over for every single person on Earth. So the logical decisions that we write as programmers is followed step by step if the computer is busy executing it. Now programs can also be called software, and both of these naturally, of course, are your instructions. And it's also important to keep in mind that the capabilities of your computer keeps on evolving. Back in the day, a computer might have filled an entire room, and a lot of people would have been making use of that computer. And its memory would probably be something like 60 megabytes. Today we will laugh at that because that does seem quite funny. Getting back to object-oriented programming. What is so good about object-oriented programming, and why are people making use of it today? First of all, object-oriented programming boosts productivity. You get to reduce development cost. It's generally easier to understand, and it's highly reusable. Let's look at an example, because I'm pretty sure if this is your first programming language or the first time you're hearing about object-oriented programming, this can be extremely confusing. Now, the basic principle behind object-oriented programming is to make your code efficient. So let's say we had to write some code to create a pet. Now let's hope that every pet has a brain, legs and ears, for example. Now we know we can have cats and we can have dogs. Now these two are not exactly the same, but they're still both pets, right? So we already wrote code for its brains, its legs and its ears. So now we specialize these two. A cat can meow and a dog can bark. Now we also know that we get different kinds of dogs. You get Alsatians and Dalmatians. And the difference between these two is that an Alsatian has long hair and the Dalmatian has short hair. And in this way we want to reuse our code in object-oriented programming, that you don't have to write these things over and over again. Computer hardware. Now there are various hardware components. You get your speakers, your mouse, your keyboard, your screen and all of those. The costs are continuously dropping. Back in the day, probably none of us would be able to afford a computer that filled the whole room. I don't even want to know what that thing cost. So the prices have come down dramatically. The size of the things has come down dramatically. I mean, we have cell phones that fit in our pocket by now, and they're affordable to the general public. Mostly microprocessors are, however, not embedded in computers. We see them more often in things like dishwashers or ovens, or in cars. They get embedded into other things because they add functionality. And there's something that we know in information technology that is known as Moore's Law. Moore's Law basically says that about every 2 years the capabilities of a computer doubles, the cost drops, and it becomes smaller. However, what most people don't realize is that Moore's Law is eventually going to come to an end. Moore said so himself. Because they realized they can only make a chip that small before it becomes so hot the components on it melt and it becomes unusable. In programming, there's also something that we call the data hierarchy. This contains bits, characters, fields, records, and files. Now, what on earth am I talking about? Let's look at it in a bit more depth. At the whole bottom of the hierarchy, we get something that is known as bits. And this is the only thing that your computer understands. It basically gets down to being either a 0 or a 1. Done deal. Whatever you do on your computer gets converted to a 0 or a 1. The game you play, the email you're reading, Heck, running Microsoft Word, eventually everything you do gets translated to a 0 or a 1 so that your computer can understand it. Putting 8 bits together makes a byte, and a byte can also be interpreted to become Putting 8 bits together forms a byte. So after bits and bytes, we get characters. Characters is one thing at a time. For example, the letter A, the letter B, the hash symbol, the @ symbol, the 7, exclamation mark, for example. It is always one thing at a time. However, this doesn't really mean a lot to us if you say A, B, and hash and @ sign there, so what's the point? So in the next step, we put a few characters together to form a field. This carries more meaning to us. So we could, for example, say the name of someone is Peter, and Peter is a programmer. That way it has more meaning, and we sort of get the idea. But just keeping random fields together is probably also not a good idea. So let's rather form a record. So we can keep Peter's record, which would now be his name, his job, his salary, and so forth. We can keep his colleague's record, which is John, and also another colleague, Amy. But we don't really want these things lying around all over the place. So we snap them together and put them in a file. And that's it for the data hierarchy. Getting back to hardware components, we get the input unit, which is used for taking any information from outside the computer into the computer. So that would be something such as the click of your mouse, a microphone, your keyboard, and so forth. We also get output unit, which is anything that takes information from inside and makes it available outside. So this can be your speaker that produces sound. Even your screen is an output device because you can clearly see things on it that's coming from inside. The printer is also an example of an output device because you print something, you get it there in a physical piece of paper. We also get the memory unit, which is also called the primary unit, which is also called RAM. Now, this is usually quite expensive and usually not very big in size. When you start up your computer and start running programs for the first time, they get put into your RAM, so that when you want to run the same program again, it starts up faster because it's kept in primary memory. However, when you turn your computer off, whatever was in primary memory gets removed. You get the arithmetic and logic unit, which is the unit that performs all the calculations, all the mathematical things. Not much more to say there. You get your central processing unit, which is the brain of the computer. It makes sure that all of the other units is doing exactly what they should be doing. Then you get your secondary storage unit. This is much cheaper than primary memory. It usually has much more capacity. So this can be like your hard drive, an external hard drive, or a USB flash drive. It keeps your information permanently. If you turn the computer off, whatever you put on your hard drive or your flash drive is not lost. It remains there. Let's go a little bit back in history. So what was the first computer language that ever existed? It was called machine language. This was strictly numerical, extremely difficult to work with, and hell, I wonder how many programs today would be able to write in machine language. This was, however, a big problem, so they decided that they have to make it a bit easier so that more people will be able to use this. So then they made assembly language, which contained a few English words and was much more easier to use. However, it was still quite difficult and didn't make a lot of sense to people. So today, we get high-level languages. An example of high-level language is Java, C++, C#, and so forth. These languages contain a lot of English words and is much easier to learn. Back again to object-oriented programming. Let's look at what exactly an object is. Let's take an aircraft as an example. The first thing you do when somebody comes up to you and asks you to build an airplane, let's hope that you don't just sit down and start building immediately. Usually you'll design it first. So you'll make some blueprints about it. You'll decide on its attributes. Its attribute is anything that you can physically see about it. The color of the airplane, the logo of the airplane, the type of aircraft. It might be a jet or a normal airplane or a helicopter, for example. Then you'll decide what its behavior should be. Behavior is anything that it can physically do, such as flying, braking, maybe it has a hooter, for example. And if we make many aircrafts, right, we usually want to keep the information hidden from one another. If we're in airplane A and airplane B gets made, airplane B is not going to tell airplane A when its gas tank is running empty. The aircraft itself will know its own properties, and that's what we call information hiding. So what's the big deal? Why is information hiding such an important thing? Let's take the example of a bank account. It might be a bit more easier to understand. Would you want me to get into your bank account, see what you have, what you've been buying? Probably not. So there's a very clear indication of where you would want information hiding. Now, in programming, to implement the behavior of something, we write methods. And where we write our code is in a little file that we call a class. Now, a program at the end of the day will contain many classes. So we have the blueprint now. It's not magically going to turn into an airplane and fly away. We actually have to create this. And this is what we call instantiation. It is the process of creating an object of a class. So we would, for example, create a class file called airplane. And then, using that class file, we would make our multiple airplanes. This allows us to make use of whatever code we have written for a particular airplane. And now the little airplane that we created becomes an instance of a class. Now, just to take a little break for a moment, don't become discouraged. These things sound like Latin or Greek to somebody that's doing programming for the first time. This is just a little bit of background, and eventually you will start to understand all of these things as you progress with the lessons. So don't become discouraged if you don't remember all of these things. It sinks in with time eventually. Keep going. So we created the blueprint, we created one airplane. What do we do with the blueprint? Do we throw it in the dustbin? Hopefully not. That would not be a pretty good thing to do. If the airplane is working fine, we would most likely reuse that blueprint. It's going to save us a lot of time because we don't have to design the same thing 1,000 times over. It's going to save effort because the blueprint is already there. We don't have to do it again. And these blueprints in industry are usually reliable and effective. And that is because of extensive testing. In industry, it's highly unlikely that you will be sitting in your own little office, not talking to anybody and writing code by yourself the whole day. You'll most likely become part of a team. And that team, before you even got there, would have been working on systems for years and years. So the code that they have written, they have tested to make sure that it's effective. And they've done what we call debugging, which is basically making sure that there are no errors in the code. And they've tuned it for performance, meaning they made sure that their code runs the fastest. Because in programming there are thousands and hundreds and tens of ways you can achieve the same result. So if I ask you to write me a program to count two numbers together, there are many ways that you can do this. But at the end of the day, we want the way that's going to run the fastest and consume the least resources, because it would be a more effective program. So we jump into the airplane. What happens? Probably nothing, right? It's not just going to magically fly into space with us. Hopefully not. So we have to somehow let the airplane know that we want it to move. So we have to interact with it. And when we interact with it, we will call a method that tells the airplane to move forward. So in programming, as I said, we use methods to implement something's behavior. So we have to physically call that method to tell it to perform its job, which in this case is to accelerate. The attributes of the airplane will represent its properties, and the attributes will follow the aircraft around. So when we start driving, or flying for that matter, the airplane is suddenly going to have this boom of color and become red, orange, yellow, pink, purple, and change to a jet and a helicopter and all that stuff. It's going to remain exactly the same way as we made it in the beginning. And likewise, in programming, when you create an object such as an aircraft, that properties will follow that particular object wherever it goes in your program. However, its information will be hidden from the other objects. So it will know its own internal functionalities, but other objects won't know about it. Now, if we did make a pink airplane in the beginning and we decide we want to change it to green later on, you can manipulate these attributes via methods in your code. Encapsulation is the fancier word for information hiding, because your objects can communicate with one another, but they don't know the exact implementation details of other objects. Let's say you have a helicopter and an airplane, and the two fly and they scrape against one another. The helicopter isn't suddenly going to know exactly how the airplane is doing what it's supposed to be doing, although the two objects have communicated, they've touched one another. So the implementation details of the two aircraft still remain separate from one another. Inheritance. We've touched on this a little bit briefly earlier on when I explained how the cat and the dog and so can continuously be specialized. So inheritance is the formal word for that. You will create a class to do one thing, such as to create dough. And then you know that dough can be used to make different things. We can, for example, make a cake out of it. We can make pizza out of it. And we can make a bread out of it. But we don't want to write the code 3 times over. We want to write it once, and then let the cake inherit the properties of the dough. Let the pizza inherit the properties of the dough. And we can go even further. You get different kinds of cakes. You get, for example, a carrot cupcake, a strawberry cake, and a chocolate cake. So we just continuously add unique features as we go down the road. And this allows us to write our code more quickly, faster. Now, what in heaven's name is object-oriented analysis and design? When we plan an object-oriented system, the formal term for that is object-oriented analysis and design. So when your boss asks you to create a new mobile chat application, it's probably going to be a very bad idea to just sit down and type immediately. That's wrong. Don't do that. It's bad. You see your colleagues do these things daily. They'll write code for 3 days and realize it doesn't work at all and start all over again. No, don't do that. Plan your program. Make use of object-oriented analysis and design. Determine exactly what you have to do. Develop some theoretical design. Review it yourself. Ask your boss or co-workers to look at it and make sure that this thing is going to work. They'll probably quickly point out errors and you can fix them quickly. And you continue this process until you have a blueprint that looks like it might work. And then you can try it out. Now, when you write a program, there's a lot of theory that goes into it, a lot of planning, and if you have to read thousands on thousands of papers, it can become boring and difficult to understand. So we make use of something called the Unified Modeling Language. Now, this is just a graphical representation of your code. So in the top bit, you will have your class name, which is basically just the file name, and here we have thermometer. Then you can give it its properties. Now the property of the thermometer is its current temperature. And then you can give it its methods, its behaviors. What must it do? It has to increase the temperature, and we want to look at the temperature. Now don't worry about this little diagram too much. We'll look at it in a later class again. Another thing that's quite important to know is that there are hundreds and hundreds of programming languages. There are over 100 programming languages. You get languages like C++, C#, Ruby, Objective-C, and much, much more. So if you want to get a job in industry, it's usually a good idea to know a few. It makes you much, much more attractive to a company than just doing one thing at a time. The Java development environment. You can start writing your own code from scratch every single time. You could also write a program, or you can be intelligent and make use of what we call class libraries. The Java API is a formal documentation that you can find online that will let you know exactly what is available to you in these class libraries. We will look at them shortly. Now these improve the performance of your program, speed your development process, and they are super efficient. Because these are the guys that make Java, that make these things available to you. They don't want their things to mess up, so they are pretty efficient. It improves the performance, well, because they are efficient and been tested by super dirty guys that are pretty good with it, and girls for that matter. And naturally it will speed your development process because you don't have to write code every single time to, let's say, access the keyboard for input. You can just make use of the stuff that already exists. So where do we find this API thing? Well, you certainly hop onto the internet, type in Java API, shabam! The first suggestion after the ad. docs.oracle.com, Java SE7 Docs API. So you just click on that, and you will be met with this screen. Now let's say we wanted to write a program that's going to get some input from the keyboard. And we know that it is in a java.util package. Now the package here is basically folders where your code lays. Mastering the API can take quite some time. I haven't quite mastered it myself, but it's good to know what's available to you. So in the top left hand corner you look for java.util. Aha, there it is. Then you click on it, and you will notice at the left hand bottom corner this little window has changed a bit. So you'll see java.util, interfaces. We're not going to worry about that yet. Much later on. We know that we're looking for a class called scanner, because the class called scanner is what's going to help us get input from the user. So we scroll down to classes, bam bam, and then you look for scanner. Aha, there it is. So you click on that, and you'll see here at the bigger window, class scanner, and a lot of text and things going on. Now this explanation of everything here will tell you exactly what the cloth scanner makes available to you, and you can use this to read in numbers and words and so forth. But let's not worry about that too much now. You'll be using it at the end of the lesson. The 5 phases of writing and executing a Java application. I'm just briefly going to touch this because this is actually pretty logical. Firstly, you have to create the program. Naturally, you can't run something that you have not created, right? And to do that, we write source code. For that, you can use something that we call an editor or an IDE. Now, editor is something like Notepad++, and the IDE is something like NetBeans, BlueJ, Eclipse, or JCreator. Now, the huge difference between an editor and what we call an IDE is that an editor will not indicate to you if you're making errors. It also will not automatically complete your words, thus the development might be a little bit slower there. However, an IDE will clearly underline in red if something is wrong, and you will easily see where your mistakes is and you'll be able to fix it. Additionally, an IDE will also help you to complete words and thus, again, increasing your development time. Sorry, decreasing your development time. It will make it a lot faster to write your programs. Secondly, you'll compile your program into something called bytecodes. Now this is brilliant about Java because you can write the same program on Windows, take it to Linux, take it to Mac, and compile it and run it, and it should work exactly the same because bytecodes are platform independent. The third thing, we will load the program into memory telling it we want it to run now. Fourthly, bytecode verification. Java will make sure that you're not wiping out your own operating system or putting your laptop on fire or something crazy like that. So Java implements very strict security in this sense. The fifth thing, the program is actually going to run. So your bytecodes now gets translated into machine language, which is the only language the computer understands, and the computer will now perform everything that you have specified. Now, you may run into some errors in this phase. Your program might crash and just end up abruptly, or you might end up with some wrong numbers. You might have wanted to multiply something by 10 and by accident multiplied it by 100, so you get what we call a logic error, because your logic failed. Then you can also get a fatal error. So you expected the user to type in a number, the user typed in a word, shabam, your program ends and it's over. So that's what we call a fatal error. Now when you use an IDE such as NetBeans, these errors will be displayed to you and you'll be able to fix them rather quickly. So now we're going to install Java. So where do we get that? Run back to the internet, you can open a new tab, and we're looking for something called the Java SDK. So you can type in Java SDK. You will see there pop up Java SE downloads. So you can click on that. Then you will see your Java Platform JDK. Now, this is what we want. So you can click on that. And here you have to accept the license agreement before you can download anything. So we accept the license agreement. And then you just look for your operating system. Now I have Windows 64-bit. So I'll download this one. So while that's starting, we also need the NetBeans IDE. So we can open another tab, and then you can just type in NetBeans. And you will see there, welcome to NetBeans. So you can just click there on the little download link. Now you can see the different packages available to you, all differing in size. The little black dots indicate you what you will be getting. Now I want everything. So I'm just going to take the biggest version here, 210 megabytes, and just say download. NetBeans IDE 8 download started. Brilliant, that's what we want to see. So you'll see here that the NetBeans IDE is downloading, as well as the JDK. Once the JDK has finished downloading, you can simply click on the little exe file icon here. And so you want to run this file, click on run. Welcome to the installation wizard of Java SE Development Kit 8. Blah blah blah. Click on next. This is very important that you notice where the file is, or the path is, where the file is going to be installed, because we will need this later on when we specify the Java path when we download NetBeans. So in my case, it's going to C program files Java and then the JDK. So just click on next. I'm happy with that allocation. They'll just confirm the path to C program files Java JRE8. Click on next. Ta-da! Java SE Development Kit 8 Update 11 has successfully been installed. So I don't really want to look at the tutorials and stuff like that, so I'm just going to say close. Alright, so now we also have to install NetBeans. So you can just go to your downloads, and then you can go to the netbeans.exe file. So you can just double click on that. So you want to run this file, netbeans 8 window.exe. Yes, I do, so I'll just click on run. Configuring the installer. Bam! Now they show you everything that they're going to install. So the installation size is 582 megabytes or something similar like that. Then we just click on next. You get the license agreement. You can read through that. I already have, so I'm just going to accept and click on next. JUnit is used for testing your Java application, which we'll maybe look at much later. So I'm just going to say that I accept this, and then I'll say next. Then it should automatically pick up the Java JDK for you. If it does not, you can just click on browse and browse to your JDK file. If you have problems with this, you can send me an email, but I doubt you would. So you can just click on next. Then it just shows you where it's going to install NetBeans. And then it's asking if you want to check for updates. The NetBeans installer can automatically check for updates of installed plugins using your internet connection. So if you want this or not, it's up to you, but I'm going to say I want it, so I'm going to click on install. Awesome, so when the installation is completed successfully, you can See here they have an option ticked, contribute to the NetBeans project by providing anonymous usage data. I don't really want to do this, so I'm going to untick that. And I'm just going to finish the install. Brilliant, and that should be that. So, it is finally time to get into the next part of the tutorial where we will actually be writing code. We will be writing Hello World. In most programming language you'll probably be writing this exact application. So let's get down to it. So you can double click on NetBeans. Might take a little while to actually start up. And also NetBeans is free to download, so if you have to pay for it, you went to the wrong place. Bam! Finally we get something. Okay, under recent projects you're probably gonna have nothing, but yeah, I've been working on a lot of applications, so there's a few things there. So this is generally what you will be met with when you run NetBeans for the very first time. So we need to create a new application. So you can go to File, New Project, and then this window will pop up. Now here you can choose what kind of application you want to make. Now we want to make a Java application, so you can click on that if it's not already selected. And then here on the right side you can click on Java application, because that's what we're going to be making. If you do not see these options, just make sure that you clicked on Java on the left hand side. Then you can click on Next, and you will see here that you can give your project a name. Now this is basically going to be the main folder in which all of your other files will be stored. So this can be a general name to your project. Now the only thing that we're going to do in this particular project is display a line of text to the screen. And it's going to be the Hello World application. So you can call it Hello World Project. Now if you get a red name down here like this, project folder already exists and is not empty. Because I've been tutoring this for quite a long time, I've been writing Hello World Project a lot of times, so I'm just going to add a number down there. You don't have to do that. The project location will show you exactly where it's going to save your project. So if you want to change this, you can just click on Browse and choose wherever you want to save it. This use dedicated folder we're not going to worry about. And this create main class, it's important that you tick this off. We don't want this. So after you've got that, you can just click on Finish. Alright. You can also just click the little X here on the start page, because we don't really want to look at this the whole time either. So on the left side, you will see here that your project was created with a little coffee cup. So we got a Hello World project here. Then you can click on Source Packages and you will see a little plus icon there. So you can just click on that and then you should see Default Package. So you can right click on that and choose New and then Java Class. If these options are not here, you can just click on Other and you can choose Java here and Java Class on the right hand side. Then you just click on Next. And now you can give your class a name. So this is going to be our main class, so we can just call it main for now. Now something that is utterly important is that your classes in Java should always start with a capital letter. Always with a capital letter. So main is a good class name. It also may not start with a number. So this here would be entirely invalid. It should not start with a number. Main would also be wrong because it may not start with a lowercase letter. If you wanted a longer name, such as main display or something like that, it's important for your classes that every word following on your word starts with an uppercase letter, and it should also be the same word. It cannot contain any spaces. But let's not worry about that too much for now. Just call it main for now, that should be fine. Don't worry about package or anything like that. And then you can just click on finish. Now you will be met with this screen here. So you'll see some gray text here. We don't really want this, so you can just highlight that all and remove it, or remove it line by line. And then you can go into this, you'll see two curly braces. You can click in the middle of them. Then all of Java applications will start its execution at its main method. So we will now be writing that main method. So the syntax and the words that you require for that is public static void main. And it's important that they are all now small letters. And if they turn blue, that's pretty perfect, because these are what we call keywords, the blue words. This indicates to Java what you're trying to do. Don't worry too much about what public and static is at the moment. We'll be looking at that in later lessons. Then you have the word main, a round brace, the word string, where S here starts with a capital letter, square brackets and a space, and then arguments. In some books you'll notice that this is RGS. It basically just stands for arguments. Then after this, after your second curly brace, your second round brace, you put the curly brace, and you can press enter, and NetBeans should automatically include the second curly brace for you. Now it's important that you make sure that the curly braces are the correct ones. So you will have can't really zoom in too much there. Aha. So you need to have that curly brace first, because it indicates your opening, well, let's just call it like your bucket. And then you will have the curly brace with its nose facing to the right. So you have a little, if you put them together, you have like a little bucket there, and all your code will go in between these. So you have your curly brace with the nose to the left, and your curly brace with its nose to the right. Then in between these two curly braces, you can click there. Now we will write system.out.println. Then you have your round braces, and you have, never mind. Like a slop. So then you click between your two curly braces, and you will write the word system with a capital S dot out dot println. Now the L in there stands for line, but don't worry about that too much. You'll have round braces and a semicolon. Now within these round brackets you will type a double quote and another double quote. And within the double quotes, you will actually type the text that you would like to see. In this case, we just want to see hello world. So we will type hello world. It's extremely important that you have all of the words and spacing and such, not spacing that much, but the words the exact same as I have it, and that you have all of the braces the exact same that I have it. So if you have any red lines or yellow lines or anything like that, you have made a mistake, and you have to make sure that you have everything exactly the same as that I have it. Now I'll just put this into Notepad quickly so that you can see the exact code. Okay, so you can see exactly what you need. You need public class main, public static void main, string arguments, system.out.println, hello world, face and another face. So that's all that we want there. So just confirm that your text is written exactly the same. Excellent. So when you're done there and you have no red lines or anything like that, you can see here's a little hammer with a brush. Just means that the compiler will check that your code is correct and get it ready for execution. So we can just click on that little brush and hammer there. Then at the bottom here you will see an output window. Poof! And you should hopefully see build successful. If you have some red text or something like that, then you made a mistake and you have to make sure that you have the code exactly the same as I have it. So if you have it green, build successful, great stuff, then we are ready to run the program because there's no errors there. So you'll see there's a little play button here. So you can just click on that and this window will pop up. Project Hello World does not have a main class set. Select the main class. So we only have the main class here and this is going to be our main class. So then you can just click on OK. Poof. And down here at the bottom at the output window you will see Hello World and build successful again. Great! You've just written your first Java application. Congratulations, pupil! Anyway, if you for some reason lose this output window or you cannot see it, you simply click on Window and then Output. Poof. And there it is. Brilliant. So this is our first Java application done. In slides, I'll make this available on Dropbox or something. You will get exactly how to actually make this application. And I'll also show you how to read your errors. Boom, and that's done. So now we're done with the Hello World project. So now we want to make something that's going to be a little bit more useful. So we want to count two numbers together. So going back to NetBeans, you can just right click on your project name next to the coffee cup. Right click and you should see all of these options. Then you can just choose close. Bam, it closes your project for you. Then you can click on File again, New Project, click on Java again, Java Application, you can click on Next. Now, this application is going to count two numbers together, so it's kind of like a calculator, a very basic one, so we can just call it the Calculator project. I'm just putting a 0 in there because I already have a calculator project as well. Then just make sure again that create main class is not checked and then you can click on finish. So you can click on source packages again, the little plus there, click it. Then you get the default package again, so you can right click on that and you can say new and Java class. Now this is again going to be the main class. We're not going to make more classes, so it's just going to be this one. So you can call it main again. And then you can just click on finish. And once more, you can see all this gray text. We do not need it, so you can just highlight that all and backspace that. We don't want that. And then you can just place your little cursor between the two curly braces. Excellent. So, since every Java application starts its execution at the main method, again we need the main method. So that is public static void main, round bracket, string of a capital letter, square brackets, args or arguments, a open face and a closing face. Brilliant. So that's exactly what we want there. Now we need to count two numbers together. So how are we going to go about that? This is where we're going to learn a little bit about variables. When you want to work with numbers in programming, you have to tell the computer that you're trying to make a number. Now for this program, we only want whole numbers, so we don't want any trailing numbers after a dot. So we want what we call integers, they're whole numbers. So if you want to create an integer in Java, you have to specify the type of the value that you're going to make, which is also called variable. So the type of the variable, the name of the variable, and then the semicolon. So in this case we want integers, right? So you'll say int and put a space and then the name that you want your variable to be called. Now in this case we need two numbers, so we can call it number 1 and number 2. It makes sense, right? Now for variables it's extremely important that you start with a lowercase letter. They also should not start with a number and also not with an underscore. They can start with an underscore, but it's probably a bad idea if you're not familiar with programming it. So we can just type the word number, and then again, if there are more than one word in your variable name, then every consecutive word starts with an uppercase. So we'll have a capital O and then NE for number 1, and then a semicolon. Semicolons are extremely important because they indicate the end of what we call a statement or a declaration. So int number 1 is what we call a variable declaration, thus it ends with a semicolon. So you can then press enter. And we know that we need a second number, right? So guess how we're going to do that? Did you guess it? I hope so. So you'll type again int, because we want another integer value, number, and a T with a capital for number 2, and semicolon. So there we have one number, and we have our second number, but now when we count them together, we need somewhere where their total is going to go. So we need a third integer value. Can you guess how you're going to declare that? I hope so. Again. So you can just type int and another space and the word total and a semicolon. So now we have the 3 values that we require. You can make a nice space there. We try to write neat code, so these that we call variable declarations, we put them on top of the method. Then you'll normally have like an open line, and then you start writing your code. It's like when you're writing a book, you'll use paragraphs and make it look neat, right? So the same counts in programming. You try to code neatly. Okay, so now we want to assign a number to our variable called number 1, and we also want to assign a number to our variable called number 2. So we will say number 1, an equal sign, and then some value that we want to give to it. So maybe 50. And then a semicolon. Ooh, my bad. Number 1 equals 50. So this is what we call an assignment. You can have as many things as you want on the right side, and it will be assigned to whatever is on the left side. So whatever is on the right side will be calculated first. You don't have to write all of these, it's just an explanation. You can have however many things you want on the right side of the equal to sign. This will always be calculated first, and then it will be stored in whatever is on the left side here, which in this case is number 1. So I'm just going to take all of this out again, because I just want number 1 to be 50. Then we also want to give a value to number 2. So I'll say number 2 equals to maybe 20. There we go. And now we want to calculate the total here. So like number 1 is a destination of 50, Number 2 is the destination of 20. Total will now be the destination of what these two are counted together. They'll say total equals number 1 plus number 2. Brilliant! So that will count the two numbers together and add their total to our variable that's called total there. Excellent. So after we counted them together, we actually want to see what the total was, right? So for that, we will need system with a capital S dot out dot println round brackets and semicolon at the end again. Now the only thing that we want in this bracket here now is the word total. And now your code should look similar to mine. If there are any red lines, you have made a mistake, so please make sure that you have everything exactly the same as I do. So once again, we will click here on the little brown broom and hammer to make sure that there are no errors in your code. So you can click on that, and if you have both successful in green down here, it means you have no errors, so that's brilliant. If you have it in red, you've made a mistake. So compare it line by line to make sure that your code is exactly the same. So if it is green, you can go up here to the play button and push play. It will again ask you, project calculator project does not have a main class set. Select the main class. So main is our main class. So you can just click on OK again. Bam! And you'll see here the number 70, because it counted together 50 and 20, which is 70, and it displays it to us here in the output window. So that's exactly what we wanted. Congratulations, you've just written your second Java application. But, however, how useful do you think this application is? If you had to give this to your friend who is not a programmer, do you think they'd be able to use it and know that they have to change the 50 and the 20 here the whole time? Probably not, and it's not really that user-friendly either. So how about we change this program a bit so that the user can type in the numbers and see what the total is in a much more user-friendly way. Great idea, right? So, earlier I showed you in the Java API that there is a class called scanner. The class scanner is used to read input from the keyboard. Aha! So we can use the existing scanner class to get input from the keyboard. Now we also saw there, let's go there instead. Poof. So you can type in Java API, and you'll see the Java 7 API Oracle documentation. You can just click on that. And the scanner class is in the java.util package. So here on the left top hand side, you'll just look for java.util. There it is. So you can just click on that. And the scanner is a class. So we don't want to look at interfaces. We don't care about that. So we just scroll down until we see classes. And we're looking for the scanner class. You can scroll down more. Aha! There is scanner. You can just click on that. On the right hand side, you get to see everything that the scanner class provides to you. Now, if we go back to NetBeans, you see here that we're working with int. So we're working with integers. So naturally, we want to read an integer from the keyboard, right? So coming back here, you can just press Ctrl and F to open the search box here. Otherwise, you can just scroll around until you find it. And then just type the word int. And you'll see everywhere where the word int is gets highlighted in yellow. Now, relatively to the top, you will see here, for example, this code allows a user to read a number from system.in. Now, this does sound a little bit like Greek if you're first starting up, but don't worry about it. just know that this is at the moment exactly what we want. So that's the bit we're interested in. Now I just have to explain a little something here. We currently have our own class, right? And our class is called main. And we know that there's an existing class somewhere in the Java class libraries that is called scanner. And it's this class that we want to have access to. But we can't just use it out of thin air, right? We have to somehow let our class, which is main, know about class scanner. It can't just use the code if it doesn't even know that it exists. So we need something in the middle here. Can anybody guess what that is? It is an object. We need an object so that the object can allow us to communicate between the two classes, so that we can go from the scanner class into the main class. Now the object that we're going to need is going to have to be of type scanner, so that we can access all of the scanner's methods. Now this will eventually sink in. I know it sounds extremely difficult, but just bear with it. It does get much easier as you go on. Alright, let's take it out of the way. So we know that the object type that we want to use is scanner, right? So that the complete top of your class in the first line, make some space there for yourself. And now we're going to write what we call an import statement. The import statement lets your program know that this is a folder that exists somewhere, and this is the class that we want. So you type the word import. Now we know that the scanner class is in the java.util package. So java.util. And now, since we already have the package structure, the last thing that we have to specify is the class name. And the class name we want is scanner. You can just type the word scanner there and end it off with a semicolon. Now it will have a little yellow underlining there. It's just basically telling you that you have written this line of code, but it's not being used in your program yet. So later on in industry, you might have like 20 of these lines, and if they're not needed there, you can just take out the yellow one and save your computer, right? It knows split-second buff processing or something. But don't worry about the yellow now. We're going to create an object now. So after your int declarations here, just push enter there. Now we're going to create an object. So for that, the object type should be of type scanner, right? So instead of int, just type scanner and then space. And this will now be used to read input from the keyboard. So I'd usually name it input, but let's stick with what the API called it. They had your scanner SC. So let's just call it SC as well. So what we just did, we reserved space in memory for scanner. So there's a little block for scanner. However, we have not yet created the scanner, we've just reserved space for it. It's like getting ready to buy a new printer. You'll first make some space for it before you actually put the printer in there. So now we actually have to put the scanner in there. And to do that, we need another little bit here. So you can say SE equals new scanner, round brackets. And in the brackets, you type the word system with a capital S dot in. And you can end off that statement with a semicolon. So just make sure you have this exactly the same again. It's SC equals new scanner with a capital S and in the brackets system.in. So now we actually put the scanner into that little block there. Bam! So it actually exists now, and we can now make use of it. So we have to inform the user somehow that we want them to type in a number, right? So before this number 1 equals to 50, you can just type system.out.println round brackets and end that off with a semicolon. And in the round brackets you can have your double quotation marks, and then you can just type please enter the first number, for example. And we try to always be kind to the user, and so that they don't get afraid or petrified and run away from the application, because that wouldn't really help anybody too much. So we try to be as polite as possible. So that's why we say please enter the first number. So now, instead of saying number 1 is equal to 50, we want to say number 1 is equal to whatever the user types in. And we know that we now need to make use of this scanner object to get the input from the keyboard. So you can backspace the semicolon and the 50, and then you can type SC, because that is the name of our scanner object. Then you can have a dot, and a lot of things will pop up, but don't worry about that. We want an integer. So going back to the API here, you'll see here that they have int I, we have int number 1, equals to sc.nextInt. This is exactly what we want. We also want to make use of the nextInt method, because that reads an integer number from the keyboard. So you can have sc.nextInt and your round brackets and your semicolon. Just make sure here that int starts with a capital letter. Amazing. But we also want to ask for a second number, right? So now we can have system.out.println, and in the round brackets you can type please enter the second number. Great. So instead of saying that it's equal to 20, we again want to make use of our object, and we called our object sc.nextInt and round brackets. Excellent. That's exactly what we want. This total equals number 1 plus number 2 is still brilliant. It's exactly what we still want. We still want to count the two numbers together. And then again we want to display the total. But just displaying the number there might be a bit confusing. 70 what? What's going on? Why is 70 there? So just before the word total, within your curly brackets, you want to make two quotation marks again, and then a plus and a space, so that you have the little orange bit here, plus and total. So between the quotation marks, you just want to type the words the total is, maybe double point and space, something like that. So it's going to be a bit more descriptive when the user sees that number, and they'll know what's going on. So if you don't have any red lines, it's good. If you have red lines, you have made a mistake. So just make sure again that your code is exactly 100% the same as mine. So if you don't have any red lines, that's brilliant. So you can click here on the little brush and the hammer. Boof. And if you see bold successful, that's brilliant. That's exactly what you want. Again, if it's red, you've made an error, so just make sure your code is exactly the same. So once it's green, you can click here on the little play button. So you'll see in the bottom window here it asks, please enter the first number. So you can just click there, and you'll see your little cursor flickering there. So now you can enter the first number. Let's make it 150, for example. Then you push enter. Then it will ask for the second number, and let's maybe make it 35. Then you push enter again, and then it will count the two together and say the total is 185. Brilliant. Congratulations! You've just written your first Java application. Woo! Okay, so that concludes the first lesson. I will make this presentation available to you, and again I go quite thoroughly through what exactly you should be doing. And also at the end there's a little appendix that shows you how to use the Java API. So thank you very much for your time, and I hope you enjoyed this tutorial and found it easy. Please rate and comment. And if you have struggled, please feel free to email me and ask me questions. Just again, my email address there is xxnovice@hushmail.com. Just make sure there that the O in the word novice is a numerical 0. Thank you and goodbye.